Let's take a look at example 13.2, heart transplants. So in 2000, it was reported that heart transplants at St. George's Hospital in London were suspended due to concern that the mortality rate was much higher than previously. According to a newspaper reports, 8 out of the last 10 heart transplant patients had died within 30 days of the procedure. In the absence of a national mortality rate, the researchers used 15% as the benchmark for comparison. Do the data from the last 10 heart transplant cases give reason for concern? Well, given that the mortality rate was 80% compared to a benchmark of 15%, my gut is, yeah, there's a problem. But that's not statistically speaking. Maybe it's actually not as big of a problem. Maybe 80% isn't that unusual compared to the 15%. So that's why we're going to get started here with this set of data. So what is the observational unit? Now, I may be tempted to say each St. George patient. Well, here's the problem. At St. George's, they probably do more than just heart transplants. It would be my guess. It's a hospital in London. What we're going to look at instead is each heart transplant case. So if we have some more specific information, we'll use it in terms of giving our observational unit. The next question is, what's the variable and type? Well, what's varying from patient to patient? Whether what? Well, literally, whether they live or die, right? Whether or not died within the 30 days. Okay, so being very specific, I'm looking at this and saying, okay, what's going to vary from heart transplant patient to heart transplant patient? And by the way, you could have said each heart transplant patient instead of case, and that would have both of those totally fine. Here we are recording whether or not they died within each of the patients died within the last within 30 days of the procedure. Now, what's the sample? What did we look at? Well, we looked at 10 heart transplant cases, the most recent 10. So the last 10 cases. What's simple? The symbol in this case being p hat, because we're looking at a proportion, and is 0.8. In words, what is that? That's the proportion of deaths among all such cases at St. George, okay? Or all such patients. Either way would be fine. Or you could have said the proportion of deaths among all such heart transplant cases at St. George. That would work very well too. So there's not an exact way. We just want to give as much information as we can that we know. The parameter of interest, well, that we don't know. That's the proportion of deaths among all such cases at St. George. Now, St. George, I don't know how many they do in general. Could we look at every single one? Sure. But they could do thousands upon thousands, and that could be data that would be hard to pull together. Now, what are our hypotheses? We want the null and alternate hypothesis. The null being nothing special is going on, that St. George has, we're using that St. George is not strange. And so we're going to look at comparing it to the benchmark, which is 15%. Now we're interested and concerned that our mortality rate is higher than the benchmark. And you're like, well, we just saw it's 80%, right? But we want to see if it's statistically significant, if it's statistically different than the 15%. Now, is it possible that the long-run mortality rate in heart transplant cases at St. John's is 15%, and the observed data happened by random chance alone, that those last 10 cases it was random? Sure, it's possible, okay? But we're curious, would it be surprising to see 10 or excuse me, 8 or more deaths in 10 cases if the long-run mortality rate in heart transplant cases is really 15%? And this is where we're going to then generate that null distribution. In other words, we're assuming that p equals 0.15, and we would use an applet in this case instead of like flipping a coin, because obviously flipping a coin wouldn't make sense because p doesn't equal 0.5. But we want to generate the null distribution of number of deaths out of the 10 cases and see what it looks like. So I plugged it into the applet. You can plug it into the applet too and run this. If I run it again, will it be exactly the same? And the answer is no. But we can generate the null distribution of the number of deaths out of 10 cases using the one proportion applet. So we're assuming that this is pi is the same thing as p, and p is 0.15. Okay, so 15%, we're assuming that's true. Our sample size is 10, and we're going to run 1,000 samples because remember, we're just doing this we're generating this just to see how unusual it would be to have 8 or more deaths in this case. So this is what the null distribution looked like. It was as it was generated, number of successes and success, and it feels unnatural in this case, but to say success, it's death in this case, because that's what success is what we're looking at in terms of what we're measuring for a statistical study. All right. Now let's think about this. It only goes as high as 5. Where's St. George? We're looking for 8 or more, as extreme or more extreme than, well, this is St. George is way out here. Okay, there are no observations. So indicate above the region that denotes this approximate p-value, and it would be out here. Well, we've got nothing out there. So let's set up the calculation, how you would calculate the exact binomial by hand. So set it up, but don't solve it and come back, please. So when I think about setting it up, I think about, okay, X, I want 8 or more. So 8 or more deaths. So P of X equals 8 plus P of X equals 9 plus P of X equals 10. We want to be careful though. We want to say what X is. X is the number of deaths. And we can say we can model this by using binomial. Maybe saying, well, why can we model the null under the binomial? Because remember, there's a success and failure. There are only 2 options. The probability does not change from case to case. So it's binomial. So we could do 10, choose 8 times 0.15 to the 8th. And hopefully this looks familiar. We did this recently. And then we would just keep going on. If we do the calculation based on what you see up here, it would be about 0. Okay. So remember, we want to estimate if it's greater than or equal to 8. We want it as extreme or more extreme than 8. I can click the exact binomial number, and that will give me this value down here, and it's really, really small. Remember here, once again, that deaths in this case, number of successes in this case is number of deaths, because that's what we're examining. The p-value, even based on the simulation, is approximately 0. Now, we don't say it's exactly 0 because there's still a chance it could happen. So when we say that approximately 0, we're going to say that the p-value is less than 0.001. That's telling me it's really tiny. Could this still happen with a really, could it happen? The answer is yes, it could happen. Right, so we don't want to say it's 0. We only would say 0 if there was no possibility at all that it ever could happen. Based on the exact binomial p-value, which we would get, I would do it in this case. I wouldn't have you obviously calculate something this long on an exam by hand like this. But just based on the exact binomial, we're going to state a conclusion in the context of the study, provide justification. So what do we have? We have very strong evidence. It's a very small p-value. P-value less than 0.001, that the mortality rate for all such heart cases, for all such heart transplant cases, excuse me, at St. George's is higher than 15%. Because to have it just happen by random chance alone would be extremely unusual, assuming that the 15% benchmark is a good estimate of what it should be, or what we're assuming it is. When the results from a study are unlikely to have happened by random chance alone, we say that the study results are statistically significant. And these are definitely statistically significant. Are the observed results from St. George's statistically significant? Oh, yes. We definitely see that. How are we deciding? We have a very, very small p-value. It looks like it would be very, very, very unusual for it to happen by random chance alone. But now are we done? Are we shutting St. George's down, putting the padlock on forever and saying we're done? Well, no. Could something unusual have been happening with these 8 out of 10 deaths? Sure, maybe there was a flu epidemic going around at the time. People who are compromised, have their immunity compromised, could pass away. So, yes, like we said at the very beginning of the course, that we get a result, we summarize it, but that's not the end. We then want to go on and look further. So, what's the next question? We want to look at more cases. I want to see, let's look a little bit further back and let's look at some more cases and see what's going on at St. George's.